Hi, my name is Steve Blyle and I'm a welder. Cutting torches like this are common in many types of shops and on construction sites. Besides welders, carpenters, plumbers, mechanics, auto body, and metal sculptors all find an occasion to use a cutting torch, and the better you learn to handle this, the more versatile it becomes. We'll be using a standard cutting torch. Pure oxygen is used for the cutting jet, and it's also mixed with either acetylene, propane, or some other commercial fuel gas to provide the preheat flames. An oxy-acetylene mixture burns the hottest, somewhere around 5,800 degrees, and that's what we'll be using for our demonstrations. Many shops and individuals prefer propane because it's less expensive and available just about anywhere. Oxypropane burns around 5,300 degrees, which is plenty hot, but the rate of burn is slower, so it takes just a little longer to preheat before a cut. Either oxyacetylene or oxypropane works well for torch cutting. I'd like to describe how a cutting torch works, and this is as much of a chemistry lesson as it is cutting instruction. When oxygen comes in contact with metal, there's a chemical reaction called oxidation. Rusting is an example of a slow oxidation process. Oxygen molecules in the air combine with molecules of the metal to form an iron oxide, which is the rust. When metal is heated to cherry red, around 1800 degrees, and pure oxygen is introduced, the process speeds up and you get rapid oxidation, or combustion. That's what the cutting torch does. It actually burns the metal, producing a form of iron oxide we call slag. Now, the reason you can make a clean, controlled cut on carbon steel is that the oxides produced from this burning process have a lower melting temperature than the metal itself, and the force of the cutting jet blows the molten oxides through the cut before the metal can melt. On some metals like cast iron, stainless steel, and aluminum, the oxides that are created from burning have a higher melting temperature than the metal. So the metal itself is melting before the oxides can be blown away. You can get these metals hot enough just to melt all the way through, but it's difficult to make a clean cut. Now, before we get started, I need to mention safety. Everything we'll be working with is extremely hot, and the potential for injury to yourself, to other people, and to property is always present. In shops or construction sites, there's safety programs to help protect you. But safety is every individual's responsibility. You need to pay attention to what's going on around you and try to anticipate what will happen as a result of what you do. These torches are hot enough to burn just about anything, so when it's lit, be careful where you aim it. The molten slag blown from the cut can easily start a fire, so keep your work area clean. Move any flammable materials like solvents, paints, or fuels away from where you'll be cutting. Pay special attention to piles of sawdust, rags, or paper. These can start smoldering and you may not notice it. Always keep a fire extinguisher for all classes of fire handy and know how to use it. Frayed clothing will catch on fire, and avoid clothing made of synthetic materials. Synthetics melt to your skin if they're burned. Wear leather boots or some other protective footwear, and always wear safety glasses. It is totally uncomfortable to take a hot piece of metal in the eye, and it's not a whole lot more fun when the eye doctor has to dig it out. There isn't any way for anybody to cover every safety situation. Safety is an attitude. When you make working safely the number one priority, you'll do fine. Okay, let's take a look at the equipment we'll be using. Here we have an oxyacetylene torch setup. These bottles come in different sizes, and typically oxygen bottles are painted green and acetylene is painted black. Even though acetylene is highly flammable, oxygen bottles are by far the more dangerous. This is a high pressure bottle filled to over 2,000 pounds per square inch. If the valve is damaged or broken, this bottle is out of here like a rocket, and anything that's in front of it is gone too. You need to protect this valve, so whenever this bottle is not in use and the regulator's off, or you intend to move the bottle, you need to use the protective valve cover, even when the bottle's empty. Acetylene gas is unstable at pressures over 15 pounds per square inch, so acetone is used inside the bottle as a stabilizer. As the acetylene is being filled, it's absorbed by the acetone, and these bottles need to be straight up and down when in use. Now, whether these bottles are in a portable bottle cart or up against the wall, they need to be chained up securely. This is real important. You don't want to be able to pull them over with the hoses or knock them over. Also, these bottles are regulated by the Department of Transportation and need to be straight up and down and chained securely when transported. This is the oxygen regulator, and before you mount the regulators, stand behind the valve opening and crack the valve to blow out any dirt or moisture. The high pressure gauge reads up to 4,000 pounds per square inch and measures the pressure inside the bottle. The low pressure gauge measures the working pressure coming out of the regulator, and this is a regulator adjuster. Screwed in or clockwise increases the pressure, and screwed out decreases the pressure. The high pressure gauge on the acetylene regulator only reads up to 400 pounds per square inch, and here again that measures the pressure inside the bottle. The working pressure gauge is marked at 15 pounds. Remember, acetylene is unstable at pressures over 15 pounds. The pressure adjuster is the same. Screwed in to increase the pressure, screwed out to decrease the pressure. Also, the fittings on the fuel gas regulator are notched to indicate left-handed thread. All the fittings on the fuel gas side of this equipment are notched with left-handed threads to avoid mixing the equipment and getting an oxy fuel gas mixture where you don't expect it. Generally, you'll have a red hose for acetylene and a green hose for oxygen. 1/4 inch is a standard hose size for normal cutting situations, and a section of 3/16 hose is often added at the torch end. The smaller hose is a little more flexible and easier to deal with in awkward situations. If you cut or burn these hoses, you can get repair parts at a welding supply store, and most have a crimping tool they'll let you use to install the new ferrules. Right here, I've installed flashback protectors. In case fire does head back down the torch, these stop it right here and keep it out of the hoses and regulators. This is a standard torch body. You have the main oxygen and acetylene valves. These are stainless ball seat valves, so when you close these, don't over tighten them. If you reef down on these, you may ruin the seats and the valves will leak. We'll be using a regular 90-degree cutting head. They also come with a head at a 45-degree angle, which I've used for beveling heavy steel, and they come straight for special applications. For general use, the 90-degree cutting head is the most convenient. This is the oxygen adjustment valve for the preheat flames, and here's the oxygen cutting jet lever. Now, the oxygen and acetylene aren't mixed in the torch body, they're mixed up here in the head. So there's 2 O-rings in this connection to seal the passageways. When you install the cutting head, just hand tighten the nut. Don't use a wrench or you can crush the O-rings, causing this connection to leak. And I like to line up the cutting head with the torch body valves. It's a little more convenient to make the adjustments. Now, all the equipment we've looked at so far can be used with either acetylene or propane. We set up on an acetylene bottle, but the same fuel gas regulator can be used on a common propane tank. The only piece of equipment that's different, depending on the fuel gas you use, is the cutting tip. An acetylene cutting tip is a one-piece tip. There's 4 to 6 small orifices around the outside for the preheat flames, and the larger center hole is the oxygen cutting jet orifice. A cutting tip used with propane is a 2-piece tip. The grooves on the inner piece are for the preheat flames. Because the rate of burn for propane is slower, you need a bit more preheat flame. Now, these tips come in different sizes, so let's take a look at a cutting chart. The commonly used cutting tips start at 0.0 for metals 1/8 of an inch thick, up to a number 3 for metals 2 inches thick. Notice that the same acetylene pressure, 3 to 5 pounds, is used on all the smaller tips, and even the large tip only uses 4 to 8 pounds. The oxygen pressure varies from 20 pounds to 45 pounds. The thicker the metal, the more pressure you need to get all the way through. We'll be demonstrating on some 3/8 flat bar using a single-aught tip with 5 pounds acetylene and 25 pounds oxygen. To make good cuts, you need to pay attention to the tip size and pressure settings. And cutting tip charts like this are available at welding supply stores. Now, if you don't have the exact size tip, you can still cut the metal. In my shop, I often use a single-aught tip to make small cuts on a lot of different thickness metals. But if you're setting up to cut a lot of one thickness, or you're going after the thicker metals, the right size tip will definitely do a better job. Now, these tips seal to the cutting head on this back surface, so you want to protect this from getting nicked or scratched. If you do get a leak there, the torch will make a steady popping sound. And you need to replace the tip. Besides the torch outfit, you'll need some cutting goggles. And this style fits over safety glasses. The number 5 filter lens is standard, and I use clear plastic lenses in front and in back to protect the filter lens. You need a striker, some tip cleaners, and a chipping hammer. You do want some good leather gloves because this will be hot. And when you're cutting metal that's dirty, rusted, or painted, keep a wire brush handy. Okay, let's load the system, adjust the regulators, and light the torch. Before the bottles are open, we need to make sure the valves on the torch are closed. We'll be adjusting the preheat flame with the oxygen valve on the cutting head and the main acetylene valve. And right now we want both of these closed. The oxygen supplies both the cutting jet and the preheat flame, so the main oxygen valve is opened all the way, and we'll leave that open. Now, whenever you open bottles, especially high pressure bottles like oxygen, you want to stand behind the valve and regulator, just in case something does come apart. Open the valve slowly so the pressure doesn't hammer the internal diaphragms of the regulator. Oxygen bottles are open all the way. This valve has 2 seats, one to close the bottle and the other to seal the valve stem when the bottle's open. So oxygen bottles are open all the way. Always use a bottle wrench to open the acetylene, not a crescent wrench or a pliers. These bottles are only open a quarter to half a turn, and leave the wrench in place. If something does happen and you need to shut the bottle down in a hurry, you don't want to have to look for something to do it with. Now, we'll make a cut on some 3/8 flat bar using a single-aught tip, so we want 5 pounds acetylene and 25 pounds oxygen. You get a more accurate reading when you adjust the regulator with the torch valve open. So I'll open the main acetylene valve on the torch and screw the acetylene adjuster in to get 5 pounds. Then close the torch valve again. Do the same with the oxygen. Open the torch valve, screw in the adjuster to get 25 pounds. And close the valve on the torch. Now, occasionally, you need to check the system for leaks. Oxygen and acetylene are too expensive to let float away, and if the acetylene is leaking, sooner or later it will catch on fire. A simple way to check for leaks is to close the bottle valve and watch the pressure gauges. If they stay the same, you're probably all right. If they bleed off, you have a leak. And you can find it with a liquid leak detector, like soapy water. All right, the pressures are adjusted. We don't have any leaks. Let's light and adjust the torch.